So this video is about the binomial distribution, and there's a number of facts that you need to know about it. Firstly, it's a probability distribution. That means it gives you the probability of every possible outcome. So it lists the probabilities of getting 0 or 1 or 2 or 3 or whatever it is, the number of successes that you get. So it shows the distribution of the probabilities. When is it used? When an action is repeated and we want to know the number of successes. So for example, if you play a game and the probability of winning every time is a third, then you can find the probability of getting 2 wins or 3 wins or 4 wins if you keep repeating this action, if you keep playing the game. So the binomial distribution will give the probability for each of the number of successes, and there is a formula for calculating the probabilities. Now there are 2 conditions that have to be true, and the first one is there are 2 conditions which must be true for a binomial distribution, and the first one is that the probability of success must be the same in each trial. So every time I play the game, the probability of winning is a third, or whatever it is. And the second condition is that the trials must be independent. So winning one game doesn't make me more likely to win the next game. So the probability is the same in each trial, and the probability of success in one trial doesn't affect the probability in the next trial. So let's suppose we've got a game, and the probability of me winning the game, probability of success, is 1/3. So what's the probability of 2 successes, 2 wins if it's a game, out of 3? So let's have a look at this as an example. So I could draw a tree diagram: success, failure, success, failure, success, failure, and then the third game we've got here. So the probability of winning 2 games out of 3, that means I've gone along there to this one here, or I get success, failure, success to this one here, or I lose the first but I win the next 2, so that's that one there. Now in each case it's a third for success and it's 2/3 for failure. So the probability of getting to this point is 1/3 squared times 2/3. And it's the same here: 1/3, 2/3 here, 1/3 there. And the same here: 2/3, 1/3, 1/3. So the answer to the question is 3 lots of 1/3 squared times 2/3. That works out to be 2/9. So notice that we've got 2 successes, so the probability of success is a third, so that's the power 2, so 2 successes and 1 failure, so that's 2/3, so it's 3 times 1/3 squared times 2/3. Why is it 3? Because there's 3 ways through the tree diagram. And this, the binomial coefficient, this 3, is what the next bit of the video is about, trying to work out what that is. So the general question is, what is the probability of x successes in n trials? So we're going to play n games. What's the probability of winning x times? So if the probability of success is p, then we've got we've won x times. It says x successes. So this p, this probability has occurred x times. So the probability is p to the power x. So that's the probability of winning x times. But if we're winning x times, then we must be losing n minus x times. And the probability of losing is 1 minus p. So it's n minus x. But how many ways are there through the tree diagram? Well, that's the binomial coefficient. Now you can write that as nx, like this. You can write it as ncx, like that. or NCX, like that. The C stands for combinations. It's the number of combinations with X successes in N trials. So we can use any one of these three notations. I'm going to write it as NX, like that. Either is okay. But what is the formula for NX? Well, it's n factorial over x factorial n minus x factorial. So let's try and sum this up. If we've got n trials and the probability of success in one trial is p, and x is the number of successes, then we can say that x follows the binomial distribution with parameters n and p. And the probability that x equals small x is ncx p to the power x 1 minus p to the n minus x. So finally, let's consider this question. If I throw 5 dice, what's the probability of getting 2 multiples of 3? Now, multiples of 3, that could be 3 and 6. So the probability of success is 1/3, because that's 2 out of 6, 2 multiples of 3 out of 6. N equals 5, so therefore I can say that x follows the binomial distribution with parameters 5 and 1/3. So what's the probability that x equals 2? Well, it's 5c2 1/3 squared, because there's 2, we want 2 multiples of 3, 2 multiples of 3 here, so that's to the power of 2, so that's probability of success is to the power of 2, and failure, that's 2/3, and that happens 3 times, because we get 2 multiples of 3, so 3 times we don't get a multiple of 3. 5c2 works out to be 10, so it's 10 times the 3rd squared times 2/3 cubed, which is 0.329.